Hi, good morning. I will be discussing about Project GUHeat accomplishments. Again, we are Project GUHeat. At this moment, you may already know our project and our project objectives. But in case you forget, just focus on this word, GUHeat. So GUHeat sounds like GUHeat, meaning to draw, to illustrate, or to sketch. So in essence, Project GUHeat aims to draw the occurrence of urban heat island phenomenon in the country through land surface and air temperature maps and models. So we also want to illustrate the unique characteristics of the 7 Philippine cities, especially in terms of microclimate. In this presentation, I will be showing to you how we started from sketch to a project generating real-world solutions. So we start with a blank canvas. No drawing, no art, just blank. So the first requirement to create an artwork is to find an artist. So that is what we did in GUHeat. We completed first the project members consist of both the research personnel and the administrative personnel. So our project leader is Dr. Ariel C. Blanco. And in the screen, you can see the researchers and the project staff and the project administrative members. So here we are very thankful to have the young and very hardworking researchers that all contributed to the project GUHeat. So we have positions like senior SRS, SRS2, SRS1, mobile developers, project leader, and etc. So this is the core team or the UPD demand team. However, we know that we need to collaborate with SUCs and HEIs, especially those working in the project sites. So we have collaborated successfully with Ateneo de Zamboanga, University of the Cordilleras, University of San Carlos, UP Mindanao, UP Cebu, and UP Visayas. So we are very thankful to these collaborators from these universities. We have Sir Mario, Sir Nathan, Sir Roland, Ma'am Anna, Ma'am Isa, and Sir Alan. So here on the screen, you can also see the researchers, the SUC-based researchers that have contributed equally to the project. Aside from those universities, we have collaborated with LGUs, especially those of the project sites. So we have visited them to request logistic support, secondary data, and to present our initial findings. Alright, now we have a canvas and an artist. The next thing to consider is to find a subject or a topic for our artwork. Remember, we can only illustrate something if we are familiar with it. So in Project GUHeat, we did a thorough review and compilation of related literature and studies to guide us on the right direction of the project. So we reviewed articles on urban heat islands, the causes, effects, GIS application, how to evaluate UHIs, how to measure land surface and air temperature, what are some mitigation strategies, and what is ENVIMET, microclimate simulation. And we also reviewed some additional field related to LST monitoring, such as geovisualization, thermal comfort, and even machine learning for land surface temperature. Aside from that, we have compiled some secondary data sets. So we did an inventory of all data that we have acquired from LGUs and other stakeholders. So here is the summary of some dataset collected, such as shapefile of CLUP, building and roads, LiDAR data. We have heat-related illness data, such as dengue. We have MET data, such as air temp, humidity, and radiation. We have air pollution data, population data, and also consumption data for the electricity and water. Here is an example meeting between the Cebu-Mandawi team and the Visayan Electric Company in relation to the request of GUHeat for electric consumption data. Okay, we have now. Okay, now that we already have the artist and the subject, we should consider next the tools that we will be using in creating the artwork. Okay, so the tool can be a pencil, a watercolor, a paint, or other medium. So the tool is very important because the product or the output will depend on it. So in Project GUHeat, we have successfully acquired useful equipment and software that will help us analyze and meet our objectives. One of which is the FLIR thermal camera, which was utilized for field validation of land surface temperature and also to acquire LST measurements of different materials. The second one is NVMet. NVMet is very important because we utilize them for simulating urban heat island mitigation and future scenarios. So we did NVMet simulation for all the sites, and most of our recommendations are output of these simulations. We also collected primary datasets such as this remotely sensed data. On the left is the Landsat, the main input for our LST analysis, and on the right is a drone data, one of the inputs for our simulation models. Now that we have the right tools, we can now start doing the real artwork. So in GUHeat, we develop different products such as this one, the algorithm for LST generation. Usually, LST computation requires long equations and knowledge in remote sensing, GIS, and even coding or scripting. So the good thing is that GUHeat has automated these calculations already into two platforms. So we developed the GUHeat engine and a QGIS toolbox. The GUHeat engine is an automated Landsat-based LST calculation implemented in Google Earth platform, while the QGIS toolbox is a compilation of our tools, one of which is the land surface temperature computation, similar with the GUHeat engine. So you have two options, which are the GUHeat engine and the QGIS toolbox for land surface computation. We also generated out or developed different maps. Example are the land surface temperature maps. So we created daytime and nighttime LST maps for the GUHeat sites. So in this map or in this screen, you can see the daytime LST map of Iloilo and the nighttime LST map of Iloilo. So on the map, you can see the temperature range of that data. Similarly, this is another map, another LST map for Quezon City. On the left is the daytime and on the right is the nighttime. Aside from the GUHeat 7 sites, we also developed or generated LST maps for the whole country from 1990 to year 2020. So this will be useful, especially to those LGUs outside our priority sites. So with this data, we can also monitor and observe the occurrence of urban heat islands in your cities. Also, we did UHI-LST site-specific studies. So those were conducted to characterize and analyze the occurrence of urban heat island in the GUHeat cities, mainly through spatial and temporal studies. So here we can see the list of the topics selected for each city, depending on the unique characteristics. So those studies are already published. So in Baguio City, we focus on the spatial-temporal effect, the effect of urbanization to land surface temperature. In Cebu City, we analyze the effect of vegetation, urbanization, and solar radiation on LST. In Mandaue, we observe the spatial and temporal pattern of LST. In Iloilo City, since they have the Iloilo River, we focus on the urban cooling island effect of water spaces. In Davao City, we observe the urban effects of LST. In Zamboanga, we observe the relationship between the monthly water consumption and LST. In Quezon City, we did GIS-based mapping of local climate zones. We also did some UHI-LST and air temperature modeling studies. So these studies aim to predict or compute the potential air or land surface temperature using different factors. So here we have three listed studies on temperature modeling. The first one is modeling of daytime LST using these factors or variables. The second one is modeling of nighttime LST using OLS regression. And the third one is a mesoscale modeling of air temperature. This one is a sample output of this paper, wherein this figure shows the warp simulated air temperature of Davao City for March 2016 at 2-meter air temperature height. We also did extended land surface temperature mapping. One is the spatial-temporal analysis of LST. This paper created those nationwide maps. The second one is the higher resolution LST mapping with Sentinel-2. The usual resolution of LST maps is 30 meters. We sampled Landsat data. However, the team developed a machine learning algorithm to generate a higher resolution 10-meter LST map. So this is an example LST map for Quezon City. So this figure shows a 10-meter LST visualization of LST. So in a closer look, here is the UP Diliman overlaid with the land surface temperature data, which is 10-meter in resolution. We also did UHI-LST and their relationship with health, environment, and water and electric consumption. So here are the factors being investigated, like dengue, water consumption, energy consumption, and environment, such as particulate matter 2.5. So here are the cities where the studies were conducted, and here are the major findings. So we also explore the positive or negative correlation and the main drivers for these correlations. We also have some microclimate simulations, and not some, we have a number of microclimate simulations. We have a total of 45 simulations for our 7 sites, and the scenarios being simulated are either mitigation scenarios or potential feature scenarios. For example, in Baguio City, we investigated the effect of, we simulated the effect of adding more buildings and removing the pine trees. The Cebu City, we investigated the effect of adding green roof. In Mandaue, we removed vegetation and added green roof. In Iloilo City, here we include site-specific scenario wherein we replace palm trees with acacia in the river esplanade. In Davao, we added more buildings and installed green roofing. In Zamboanga, we want to know the effect of adding the SM building and more condominiums. And in Quezon City, we simulated the effect of adding more trees, removing trees in Visayas, and also installing green buildings. Here is an example of a map showing the effect of adding green buildings in Timog Tomas Morato. That is early, and you can see here the change in temperature. This is another differential map showing the effect of removing pine trees near the SM in Upper Session Road, wherein in this example 1 p.m., those areas in red are those areas with increased temperature due to the removed pine trees. Okay, now that we already have the product or the artwork, the next thing, or before we end the artwork, we need to edit something or to apply the so-called final touches. So in GUHeat, one of the final steps is to validate our outputs. So we did fieldwork activities such as in the left photo. So this shows the field measurement of land surface temperature using infrared thermometer, and the FLIR camera. On the right is the deployment of hobo air temperature sensor, which serve as the validation data for our microclimate simulations. Okay, so now we finally have an artwork. Our artwork is finally completed. So at this stage, the artist will have two options. One is to keep his work or art in his room, which will serve as a personal collection, meaning only him can see it or appreciate it. The second option is for him to exhibit the art for public viewing, so many people or more people can see it, appreciate it, or maybe learn from it. So obviously in Project GUHeat, we need to do the second option. So we need to disseminate the workflows and products of Project GUHeat, and we have four strategies to do it. The first one is through capacity building, wherein we train our SUC partners and even LGUs with our technologies and algorithms. So that is through our project planning workshop trainings conducted in Quezon City, Baguio City, and also Davao City. On our last training, we did a hands-on training on EnviMet and Palm for Use software. So of course, we need to distribute the generated maps. So here we have distributed the maps to our partner LGUs. We also created maps for the cities within the National Capital Region, and we also visited them for us to present the maps and to discuss the project outputs and objectives. The third one is what we are doing right now, the webinar series. So even we have a pandemic, we have to share the main outputs of the project, especially the recommendations for policymakers. So I think this is effective as discussed earlier by Drew. The last one is the open access tools and resources. So in our project, we developed a mobile app, the GUHeat website, and the eNet, an ebook for workflows and tools by the project. So a presentation later will be discussing this thoroughly. So I will just skip and present it to you just this and present to you just this slide. Next, we have developed and uploaded many IECs such as trivias, IECs on our products, and IECs on the Project GUHeat sites. So these are uploaded in our official Facebook page. Lastly, we also have uploaded, we also have published papers under the Project GUHeat. So during our year one, we have published 10 papers, including mostly those papers published in the ISPRS archives. In our year two, we have published 3 papers this month, and we are expecting more papers to be published as we are still writing some results, which are still ongoing. I mean, the write-up is still ongoing, but for the results, we have already completed all of our research work. All right. In summary, Project GUHeat has successfully developed useful workflows, algorithms, and tools that can help in understanding the occurrence and development of UHIs in our country. We are sure that our products will be shared to the public via tools and online resources, as explained earlier, and we will continue to do UHI related studies through future collaborations. Lastly, with the aid of the GUHeat products, we hope that the LGUs and other collaborators will continue to draw and realize their own plans for a more livable, climate healthier, and smarter cities. Good afternoon, and thank you for listening.